I'm Ellie, and I'm going to be one of the officers presenting this workshop today. Next, we have...
Where's Ted?
Hey, I'm Ted. I'm also one of the officers that's going to be presenting today.
All right, and I'm William. So let's just get started. First of all, thank you for coming out to our third and last workshop in the forensics analysis workshop series. This will also be the last workshop of the quarter. Afterwards, we're going to have like a mini competition called CTF After Dark, testing with problems from all of the past 3 workshops, as well as I think a puzzle hunt. So that's like the plan for the rest of the quarter. But for this week, we have something very exciting. It's called memory forensic. And so you can view the slides here if you want. I'll just keep that up for like 5 seconds. Oh, and also one more thing. It's very important. I realized this. Apparently the links.ucla.acm.com website doesn't support HTTPS. So you have to use HTTP. If you use HTTPS, it just does, the server doesn't respond, I think, or at least last time I checked. All right. So before we actually begin on the content, which is actually pretty short for this week's workshop, hopefully everyone has downloaded Volatility. Maybe try to set it up. We'll also have like breakout rooms dedicated to helping you set it up, and as well as the demo memory dump. I think I mentioned this before in the general channel Discord, but you know, like the past 2 workshops, we've been dealing with files that are like maybe a couple kilobytes to a couple megabytes of size. But this week, all of our memory dumps, these files are on the order of like a gigabyte or so, and probably like a couple hundred megabytes compressed. So it's very important, if you want to like start working on stuff immediately or follow along with the demo, just like start downloading the file now. And then hopefully by the time we finish the workshop, it'll be finished downloading, and then you can also like follow along. Okay, so first of all, what exactly do we mean by memory forensics? Well, the memory part refers to RAM, or random access memory. And I guess for those of you guys who maybe are more familiar with like how computers work internally, or maybe like built your own desktop before, you know that this is like some component, like an essential component of a computer that basically acts like a big data storage device. And so what separates RAM from like your normal kind of data storage, like a hard disk or something, is that RAM is used for non-persistent data. And non-persistent in the way that as soon as you reboot a computer, right, you turn it off and turn it back on, none of your RAM data is stored, right? The goal of the RAM is simply to facilitate your computer usage. And so that can be anything from just how the operating system manages like the various processes on your systems to the application data itself, like whatever's on its stack or heap in terms of memory. And this can also be like very low level things as well, like your entire screen buffer, right? All of these RGB pixels, well, they have to be somewhere. They're definitely not stored on your hard disk. And so they're actually stored in your RAM as well by the operating system. And that's basically what's continuously updating. Like as soon as you reboot your computer, it doesn't care what your screen was like the last time you ran you had your computer on. It's just something that's there ephemerally, basically. And you'll learn about this more, especially in CS 111, but the types of data that go into the RAM is what we're basically trying to recover in this workshop. Okay, next slide.
Yeah, so now that we kind of have an idea of what RAM and memory is, so what does dumping memory exactly mean? All that it means is really you're just taking a copy of everything that's in RAM at that moment in time. So it's like you took your computer, you did some stuff, like go on the web browser, go to Chrome, searched up some website, type some essay for your class, and then you just freeze that computer right then and there, and then just kind of grab everything that's in memory and put it in a file, which is what you downloaded in the demo file. That is why it's so chunky, because it's just your entire computer in the memory. Well, not the entire computer. It's the memory of the computer at that moment in time. So we have a question. What about when you have your computer? Remember what apps were open after shutting off? So those would be saved into a specific setting in like your hard drive or hard disk. So that has to be saved somewhere else, not in memory. So then your computer, when it starts to back up, it will read that file to see what it needs to open right away. Does that make sense? Cool. Yeah, so dumping memory seems like a pretty straightforward concept, but then like you might be wondering, like, why would we do this? Why do we care about the memory on a computer? So one thing is that you could be using this to identify malware. Maybe like there's something bad on the computer and you don't want to like have the computer open and messing with stuff while the malware is there. You might want to be able to identify it without the live computer being on. You can also be using it to retrieve lost info. As you'll see in the demo, there's a lot you can get just from the memory dump, and that's what you can use if you got yourself locked out of a computer per se. And then you can also use this for forensic investigation, which is kind of like what our challenges would be like, where you have a dump of a computer and you want to get whatever information you can out of it. Yeah, so tying it all together, you can look at memory to figure out all these information. But one way to do this, obviously, to look at every single byte and every single zeros and ones in the memory dump by hand, which is very absurd and very gross. So this is why someone made a tool called Volatility. And it basically just parses everything in the dump and then retrieve it and then print it out in a way that it's easy for humans to read and understand. And the way it does it, it has all these different commands, which they call plugins, because you can, because it's open source, so a lot of people can write their own plugins and then add it to Volatility to be used. So we've attached a cheat sheet because there's so many different commands that it's not really worth like just memorize everything. It makes more sense, it's a lot easier and more practical to kind of reference the cheat sheet or documentation to figure out like what it is I want to do and how can I do that.
So yeah, so here is my screen. And so to get to this page starting out, I'm going to show you how to install it in case you haven't. So we have this link on our website at events, memory forensics, so right here. And basically what you want to do is download Volatility here with this link. Or you also want to make sure you have Python 2.7 installed. But yeah, so you want to download the memory dump by clicking here. I've already downloaded it, so I'm not going to do it again, but you click here. You click here for Volatility, and you click here for the plugins. And those are the three things you need. So down here, you can see I already downloaded it. Actually, I'm going to show you how to do the plugins. So when you go to this GitHub page, you just go here and you click download zip, and then it'll give me this zip file right here in the bottom left. Okay, so I've moved those to a directory here. And then so I'm going to be working out of this directory for the demo. So I've moved the plugin zip, the Volatility zip, and I also moved the memory dump zip here. I already unzipped it because it kind of takes a while to do that. So I didn't want to waste your time here. But yeah, so I'm going to be working through this in this directory. So so the first thing I want to do is unzip all my files. So I've already done the dump as I said before, but I'm going to do these ones because it'll take too long. So I'm going to use the unzip command in this directory. So it's going to unzip that, and then also the Volatility plugins master. So I'm going to do that, and there we go. We have this Volatility master folder and this Volatility plugins master. So I'm going to remove these zip files because I don't need them anymore. So yeah, now I have just these three files here. So now I'm going to teach you how to get started with volatility. So the first thing you want to do when you're trying to use volatility is run the Python script. I'm actually going to move this up a bit. Hold on. Here's my, okay. So we want to go into the directory. We want to access the Python script, because in this directory, I'll show you what it looks like. We have, we have these, my bad. Let me do that again. We have these files, and then we want to run this Python script. So I'm going to go into the directory and execute this. So volatility master / vol.py. And following that, I want to specify the file. So I'm going to use these verbose flags. So I'm going to do -- file and specify the file. So it's called, I believe it's called workshop.elf. Yeah. So that's the dump I want to analyze. And then I'm going to put in my command. So I'm going to put in, okay, this is a good point. So when you download it, you might have a permission issue when you unzip it. So you want to change the permission to give yourself executable permission on the volatility script. So you'll do chmod +x, and then you'll specify the vol.py. And now if I run this command again, it should work. So yeah, so this might take a while to run, so I'm going to explain a little bit about what I'm doing. So yeah, I'm this volatility.py, vol.py, specifying the file workshop.elf, which is the dump I'm trying to analyze, and then I'm putting the command I want to use, or it's known in volatility as a plugin. I'll use plugin and command interchangeably throughout the demo, but yeah, so what I'm doing right now is trying to find the OS, or the profile of the memory dump. So yeah, all of our dumps for the challenges and the demo, they'll be the same profile or the same OS. So you don't really have to do this step when you are doing the challenges, but I'm just showing you. So yeah, as you can tell, this command takes a little while, but it's going to find the candidates for what kind of OS the dump came from. And I'm going to use that to preface all of my commands in the future throughout this demo. So just going to give it a little bit longer. Okay, there we go. So we have the suggested profiles. So you could just like go ahead and test these different ones to see like which one you have, or if you have other information, of course you would know. So I actually, I just happen to know that this memory dump is going to be using the this Windows 7 service pack x86. So I'm going to specify that before I type in the command. So this is my command from earlier with the -- file. So I'm going to do -- profile as well. I'm going to specify it as this Windows 7 like SP x86. So, and then now I can type my command. So what I'm going to do is type in PS list, which is process list. And as you can see, there's like a whole bunch of processes. Most of them I don't really care about, like these Windows processes and things. And also if you see like VBox service or anything like VBox, it's because we dumped these memory dumps from a virtual machine. So you can kind of ignore those. But yeah, so I look through, I'm seeing like what's interesting. There's a bunch of Chrome exes.
Isn't it demo dump.elf?
Sorry, what'd you say?
Isn't the demo one demo dump.elf?
Oh, is this the wrong one?
1 hour later.
All right, cool. We're back on track now. So I can do the same thing, just specifying the -- file as demo dump.elf, and it's this, and we're back on track. So so yeah, as you can see, there's a bunch of processes, Explorer, and then I'm trying to look for, I'm looking at this notepad.exe, and I'm really interested in what could be there. Like, was he making a text file? Like, was the person putting their, like, some cool information in a text file, and I want to kind of access what they're doing there. So that's going to be my basis for what I'm going to do next. So I'm going to test if the notepad command works, but it doesn't support this profile. So I'm going to have to find some other way to get at the data that I want. So let's use something called memdump. And memdump I'll need the, yeah, let me just type out the command. So I'll need to specify the dump directory for memdump. So I'm going to just put dot, which specifies the current directory. And I also need a process ID. So I'll specify that with the -p flag. And then I'm going to look for the, so as you can see, it says process ID in this column. So I'm going to look for a notepad's process ID, which is 924. So I'm going to run this. And then it's going to create a file in the dump directory, which is the current directory, called 924.dmp. So we have that here. And yeah, so I want to find the strings in this dump file. Because as you can see, if I just output the dump file, it's pretty unreadable, and I wouldn't go through that by hand. But oops, I want to use this, find all readable strings in the file, and I'm going to pipe them to a grep, which finds a word that I think will be in there. So maybe something like flag would be a good candidate if I'm doing a challenge. So let me try that. It's gonna find all the strings with that flag string in it. So as you can see, it found a flag this is a flag. So that's one way to get at the information. But as you can see, I only got this string, and you know, there's some other ways to actually get like all the information, or the other information that's in this that has to do with Notepad or a text file. So let me actually do that by using something called Mft Parser, which I'll explain after I run the command, because it takes a little long. So I'm going to do make directory and make a directory called output dir, and this will be for the output of Mft Parser. So give me a moment while I type this out, and then I will explain. So oops, I'm going to copy this, and I forgot to add it to the end of my volatility string. So you always need to specify the file, the -- file, and the -- profile when you're running a volatility command. So I'm going to run that, and it says output directory is not a directory, because I spelled output wrong when I created the directory. So it's actually called output directory. So I will just do that. It doesn't really matter. Because it started creating that file as well. So let me remove. Okay, so it's good to see some like troubleshooting here. So I'm gonna remove this file that was created, and then run the command again. So yeah, you can press up to. Okay, so yeah, I'm gonna explain this command now that it's running. So as always, we have the -- file with the file, the dump specified with the -- profile, and then we do Mft Parser. So I'm specifying the output mode to be body, and this equals is optional. I don't know why I put it. you can either put like a space here or an equals. It's pretty much the same thing, like as I did for these flags. So yeah, I specified the dump directory, which is the output directory that I made up here. And then I'm also specifying the file for the output to go in. So it'll create this file called demo mft.body. So it's done now. So I want to actually look at what is in this demo mft body. So as you can see, there's a whole bunch of file information here. Too much for me to kind of manually go through without like narrowing it down a bit. So I'm going to pipe this to a grep once again and put in text. So I want to find all the text files here. So yeah, and what grep does is just anything you input to it. So it's getting this output from the cat through this pipe, and it's going into the grep, which looks for txt in the output or in the input to grep. So it's looking through all these files for things with txt. And so I see a bunch of txt files which are not really interesting to me. They're like temporary files or like log files and things like that. But I do scroll down here and notice something called ACM cyber.txt, which is pretty interesting. So I kind of want to look into that. So I'm going to grab this offset, copy it to my clipboard, and I'm going to use that for my next command, which will find the output file and look at the contents of ACM cyber.txt. So earlier I specified the output directory or the output directory. So I'm gonna show you what's in there right now. Yeah, you want to read the EULA. Yeah, so you can go and look at the EULA.txt if you want to, because it sure is very interesting. But anyways, yeah, so I'm showing you what's in this output directory. So it's a bunch of these files, which are .emp files. And so one of these has the file data of ACM cyber.txt. So the way I'm going to find that is I'm going to cat the file which has this offset as the name. So these asterisks are like wildcard characters. So like it'll match anything that's before this offset and then after the offset. So I'm going to find the file that matches this format and output it with cat. So let me do that. And as you can see, we find the contents of ACM cyber.txt. So it says, today I'm going to blah, 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 and it has flag. This is a flag. So we found that earlier, but now we get to see the full picture and see some other text here. And there are some other ways to get the contents of files. There's this command called dump files and other stuff, but you can also look at some online resources and documentation to see how those things work and how you can use them. So great. So that is almost everything I want to show you, but I have a few more like extra commands, some useful commands that will be helpful, potentially helpful for the challenges. So let me find here we go. So I'm going to replace the Mft Parser stuff with a command called clipboard. And clipboard is pretty self-explanatory. It tries to reconstruct or retrieve the data that was on the clipboard. Excuse me. So I'm gonna let it run. It should only take like about 10 seconds. And if it successfully works, then we have the data that's on the clipboard. So you have this Unicode text, my password 123. So yeah, so maybe the person who was using the computer before the dump had their password on the clipboard, and we were able to recover it. Another potentially useful command is Netscan. So Netscan is kind of similar to like the Unix, Linux Netscan command. Has some differences, but yeah, you can look up the documentation for this. I'm not going to explain it here, but if you think you'll need it if you think you need it, then you can, there's some great resources online, or you can ask an officer. And one last thing is plugins. So that plugins folder I made, downloaded earlier, this volatility plugins master, I'm gonna actually use one of those plugins. So these are just made by community members, and they're not bundled in with the standard volatility. So let me try to use one of those. So when I want to use a plugin, I have to specify, in addition to the file and the profile, I have to specify the plugins directory. So I'm going to do -- plugins, and then I'm going to specify the volatility plugins master. And that will allow me to use any of the plugins that are in that directory. So I'm going to do Chrome history, because that is the one I know that's in there and I want to use it. I want to find the browsing history of the Google Chrome on this memory dump. So as you can see, we're able to recover these entries, and let me actually do that again, make it bigger. We're actually able to recover these entries, and as you can see, this person was very obsessed with ACM. So they were searching up why is ACM cyber so cool, blah, blah, blah. Just a normal web search history. And they also really like cats and cool, funny cat videos. Yeah, so this is, you can get a lot of information from just a bunch of bytes that were dumped from memory, not even the hard disk. So yeah, that's pretty much it for the demo. And always keep in mind that I didn't really magically come up with these commands and things. I referenced the cheat sheet, which is linked in the slides. Also looked at a bunch of online resources, and it's always a good idea to look at documentation and online resources to kind of help you navigate through like new technologies and things.
So I'm gonna do a run through of give me some hash browns. Yeah, so the question says I'm logged in as IE user. What's the NTLM hash of my password? Wrap the hexadecimal flag, hash in the flag. So I'm looking at this, I'm like, okay, well, maybe like, so this is pretty straightforward. Like I need to get this hash, whatever it is, and it has to do with a password. So if I go to the slides to get to the cheat sheet, first thing I want to do is obviously look for whatever command that can help me do that. So maybe I can like search for password. So, okay, password recovery, that sounds very promising. And here we have exactly what we need, which is dumping the NTLM hashes. So for reference, what an NTLM hash is, like encrypts and hashes the password of the accounts so that to store it. I got the volatility command, right? And then I've got the file that I need, which is workshop.elf, and I got the profile. And I'm just gonna run hash dump to see if this works. It's gonna take a while. I probably should have run it first. People are typing in the chat. Tells a joke. I don't have any jokes. Okay, so you should get like these output where it says like administrator and then numbers and some letters and numbers and some more letters and numbers. So you can Google what this format is, but I can just also tell you right now. So what this is first it tells you the username of whoever's on this computer, and it has a user ID. Then this is like some dummy stuff, and this is the actual NTLM hash. So this dummy stuff, if you're curious, it's I say it's dummy because this used to be the what's called a landman hash, but it's been deprecated because it's very bad, and like it's basically just really bad way of hashing stuff. So Windows don't use it anymore. They use NTLM hash. So right now here, like this is just dummy, and it should like you see how they all start with AAD3. I mean, they're all even the same value, so like it's not important. So the NTLM hash is what you want, and the question asked for the NTLM hash of IE user, so it would just be this part, and if you just copy this, and then wrap in the flag format, and then put it in, then you should get it.